A stabilizer weighing 25 grams and measuring 2 by 2 centimeters that stabilizes at the level of large gimbal stabilizers? Yes, it's possible. Introducing the NiYien Senseflow Gyro Stabilizer, a device that helps stabilize your video and turn shaky footage into smooth, stabilized video without jelly effect or other electronic stabilization artifacts. It even stabilizes cameras that don't have stabilization capabilities to begin with. In this video, I will explain what this device is and how it works. And here we need to start with GyroFlow. Some of you may have already heard of it. In short, GyroFlow is advanced video stabilization software that uses gyroscope data to remove shaking and blurring, providing smooth footage that even built-in camera systems cannot always deliver. GyroFlow stabilizes video based on camera movement data, which is much more accurate than standard stabilization in DaVinci Resolve or Adobe Premiere. GyroFlow was originally used to stabilize drone footage, but this method has gradually made its way to regular cameras. GyroFlow obtains data from the gyroscope by reading it from the metadata of the video file recorded by the camera. Unfortunately, not all cameras are capable of outputting gyroscope data to their video files, and this is where NiYien Senseflow comes into play. Essentially, the NiYien device is an external gyroscope designed to work with cameras that do not support gyroscope data output for further stabilization in GyroFlow. NiYien Senseflow is a Chinese development, which at the time of this video's release has been available in China for about a year and a half, and is only now beginning to reach the Western market. The device is unique, with no analogs currently available. Previously, there were only private developments using ready-made gyroscopes that were additionally modernized. The downside of such devices was their complexity and clunky appearance. They looked like the work of DIY enthusiasts with protruding wires, large external batteries, and, on top of that, difficulties in synchronizing video with gyroscope data. Some also used the GoPro as a gyroscope, attaching it to the camera and then trying to synchronize the GoPro gyroscope data with the video files shot on the main camera. The same was done with regular smartphones. These methods worked, but they were not very convenient. This device was originally designed to work with GyroFlow, and in addition to the device itself, special software was developed to synchronize gyro data with your video files. Let's take a look at what's included in the package. In addition to the device itself, the package includes a 4 GB SD card, a card reader, and a USB Type-C cable. Senseflow has a metal body and a built-in battery that allows you to record about 35 hours of gyro data, which is enough for 3 days of shooting. It has a small informative display, a memory card slot, 4 control buttons, a status indicator, a Type-C interface for charging and data transfer, and a shutter cable interface. Yes, it is possible to use a cable to synchronize with the camera, but in fact, this is not necessary, since synchronization works completely wirelessly. A hot shoe is used to attach the device to the camera. It doesn't matter if your camera's shoe has electronic contacts or not, it's only needed to attach the device. So, how does it all work? In this video, I will not give detailed instructions, but will describe it in general terms. Detailed instructions are available on the device's official website, where you will also find video tutorials. To get started, you need to perform the initial setup of the device, which is done once. Download the NiYien tool program and download GyroFlow. Install both programs. To use NiYien tool, we need to run GyroFlow once. Launch the program and scroll to the bottom of the right-hand menu, where you can immediately install the GyroFlow plugin for Adobe or DaVinci. Let's move on to the device's workflow. After purchase, it is recommended to calibrate the gyroscope through the device menu. The manufacturer recommends calibrating every 3 months if the device has not been used during that time. After calibration, connect the device to your PC. The program will prompt you to update the firmware on the device. You also need to set your time zone. Next, in the program, we create a profile for the camera we are shooting with. If you are shooting with an autofocus lens, the software will determine the focal length itself, as it will be in the metadata of the video files. If you are shooting with a manual lens or a lens that does not have an electronic connection to the camera, set the focal length in the NiYien tool program. This completes the initial setup, and you can now proceed to shooting. At the beginning of each shooting day, we need to create 2 synchronization files, which we will later use to synchronize gyro data with all the videos shot that day. Attach the device to the camera using the hot shoe mount. You can attach it to the top, side, or bottom of the camera. The main thing is to specify in the program which side you attached it to. By default, the device is simply attached to the top. Turn on the device and the camera. Simultaneously press record on the camera and on the device. You don't need to be super precise and time it perfectly. Just press as accurately as you can and record a video less than 10 seconds long. Then simultaneously turn off the recording on both the camera and the device. Repeat the same process again. This will give us 2 video files and 2 files with gyro data, which we will use to synchronize all the other videos shot during the day. After that, we simply turn on the recording on the device and forget about it for the rest of the day. You can use the camera as usual, turn it on, turn it off, record, or don't record. It doesn't matter. The main thing is that recording on the device is turned on during video recording. The device itself can also be turned on and off during the day, but there is no point in turning it off until the end of shooting. The battery lasts for 35 hours of recording, and the data does not take up much space. The next step is to synchronize and stabilize the video. Transfer the gyro data from the device. It's best to use the card reader that comes with it. Open the NiYien tool program and simply drag all the videos into it, along with the gyro data. Go to the match list menu, where you will see all your videos. The first 2 will be the synchronization videos that you made before shooting. Click on the first video, and then in the window that opens, specify the path to the first gyro data synchronization file. Close this window and click Match. This way, we have matched all the videos with the gyro data, and now we click Export. Next comes the synchronization process, which takes some time. In my case, synchronizing 72 videos with a total duration of 10 minutes and a size of 227 gigabytes took about 10 minutes. Synchronization is the longest part of video post-processing. After that, stabilization in the video editor takes no time at all, since the files are already synchronized. After the process is complete, a synchronization file for GyroFlow will be created for each video file. Open your video editor. I will be working in DaVinci. All that remains is to load the GyroFlow plugin and apply it to all videos. And that's it. We instantly get stabilized videos throughout their entire length. You can also play around with the settings in the plugin. For example, increase or decrease the degree of stabilization with the smoothness slider. For example, you can reduce the stabilization strength if you want to preserve the effect of handheld shooting, but remove the microshake of the camera if you are shooting on a light setup. Here is a frame without stabilization, where the microshake of the camera is very noticeable. And here, we remove the microshake. The result is already good, and we have retained the effect of shooting handheld. If we set the smoothness value to the default, we get a result that is as close as possible to a large gimbal stabilizer. The camera practically hovers behind the girl. Another interesting feature is horizon lock, which locks the horizon so that the frame always has a level horizon, regardless of how we held and moved the camera. Another important part of the stabilization process in GyroFlow is rolling shutter correction. Most digital cameras are equipped with sensors with a rolling shutter effect, which means that the image is not captured in its entirety, but is read sequentially from top to bottom. This makes the recorded video prone to distortion and shaking when there is significant side-to-side movement. You can observe this effect by quickly moving the camera left and right and looking at straight lines. They will be curved. To compensate for this distortion, GyroFlow needs to know the frame readout time, which is the time it takes for the sensor to capture the entire image. Since the NiYien tool already has these values for all supported cameras, the rolling shutter correction process happens automatically. Perhaps at first, the whole process may seem a little complicated, but that's only at first glance. In fact, after the initial setup of the device, all you need to do is shoot 2 short videos for synchronization before shooting. Then, upload everything to the synchronization program after shooting, and that's it. You can now work with your stabilized videos. Personally, when I used the device for the first time, I was amazed by the result. I have a fairly compact camera, the Sigma FP, without any stabilization at all. Due to its lightweight and small size, there was always a slight shake in the video, in addition to the generally unstable video. Of course, standard stabilization in DaVinci partially solved the problem, but the result with this device is incomparable. Finally, I can shoot on the go, from a vehicle, or even while sitting on a bike and get great results for such shooting. You can finally forget about the jelly effect. The thing is that conventional electronic stabilization tries to predict the camera's movements, but it doesn't have the data to do so. That's why we see various artifacts, image ghosting, jelly effects, and, in general, stabilization that is not as smooth as we would like to see. All this applies to a small camera like the Sigma FP. But if you use the device on a large camera with a heavy rig, where you have a better grip and, accordingly, no microshake when shooting, then the stabilization result will be as close as possible to using a Steadicam. But at the same time, you don't weigh down the camera, you don't add to the size of your rig, and you don't need extra wires. I switched to Sigma after Blackmagic 6K Pro. I needed a compact camera, and I didn't want to use a large external stabilizer at all. It takes up space in my bag, and it takes time to get it out, turn it on, and set it up. With the NiYien Senseflow, which I don't turn off during the entire shooting day, I just take out the camera and start recording video without any prior preparation. Now it's time to talk about some of the limitations of using the device. First, there is a list of supported cameras. What you see on the screen is supported at the time of the video's release. The developer updates the list quite often and can even add support for your camera upon request, if possible. The thing is that older cameras, such as the Panasonic GH2, do not contain the necessary metadata in their video files to work with NiYien tool. The good news is that some camera models from Sony, Blackmagic, Canon, and GoPro action cameras are capable of outputting data from their gyroscopes in their video files, and therefore they are directly supported by the GyroFlow program and plugins. With these cameras, there is no need to use this device. You can work directly with your video files using the GyroFlow program and plugins. You can find a list of GyroFlow supported cameras on their website, in the docs section, and then in supported cameras. The second point is the recommended shutter speed of 1/120 for standard shooting and 1/200 for shooting fast-moving objects in the frame. Here, I will talk in more detail about this feature of all electronic stabilization systems. And the problem here is not with the device itself. When using any electronic stabilization, it is best to avoid motion blur. Motion blur cannot be removed in post-processing. So if you shoot video and then stabilize it in post-processing, the motion will remain in its original direction while your video will have a different stabilized motion. After stabilizing the video, the movement of the frame changes, but the motion blur remains in the original direction. This creates a distorting effect and spoils the footage. If you use a long exposure when shooting, you get a video without motion blur, without blurring, a completely clear video, and in this case, you don't risk getting these artifacts. In post-processing, you can add motion blur after stabilization in your video editor. In film production, it is common practice to use a 180 degrees exposure. This exposure is good when your camera is physically stabilized, on a 3-axis gimbal, crane, or slider. However, this rule does not work when using any digital stabilization. This method is widely used in filmmaking because cameras are physically stabilized on set, shots are planned, and camera movements are predictable. But this rule does not work in scenarios where you are shooting handheld, shooting fast shots, or moving on the go. At the same time, you need to understand that you can shoot at a slower shutter speed. It all depends on the shots you are taking. If you are shooting static, calm shots without much camera movement, you can safely shoot at a shutter speed of 1/50 or 180 degrees without the risk of getting artifacts during stabilization. When shooting more dynamic shots, you can increase the speed to 1/120 or 90 degrees. And if you are shooting shots with very fast movement or with strong camera shake, then in this case, you need to set the exposure to 1/200 or 45 degrees. For extremely fast movements in the frame or of the camera itself, the exposure can be increased even further. There are no restrictions here. The main thing is to get the clearest possible frames without blurring to achieve stabilization without artifacts. The next thing to know is that the device does not currently support zooming. You can shoot with zoom lenses, but the zooming itself is not supported. You can shoot at 17mm, switch to 35mm, then to 50mm, and it all works fine. But stabilization of the zooming itself is not supported. It is also important to understand that this is a type of post-stabilization, so stabilization will occur at the expense of a small crop of your frames. The size of the crop directly depends on how much the camera shook during shooting. Here is an example of a crop shot on the move. You can see the size of the crop. And here is an example of a stationary shot where I just stood still and tried not to move the camera. The difference in the size of the crop is clearly visible. When shooting on the move, you can take a frame slightly wider than necessary, or use a slightly wider lens. Some may find the crop too large, but take a look at the original video and the stabilized one. I think it's worth it. Plus, always remember that you can adjust the stabilization strength with the smoothness slider, thereby reducing the crop of your frame. Also, this device does not work with any other stabilizers before use. You must disable all built-in stabilization on your camera and lens. Combining the device with other axial stabilizers will not work either. The Chinese have come up with an interesting device, and I think many of you didn't even know that something like this existed. In essence, this is another way to stabilize your videos, in addition to various gimbals or matrix stabilizers. Previously, only enthusiastic hobbyists were involved in this type of stabilization, but now we have a finished product that is suitable for both amateurs and professionals. In terms of stabilization quality, the device outperforms many matrix stabilizers, such as the new Nikon ZR, and comes close to the stabilization quality of stabilizers, gimbals, and other stabilizers. Yes, it is probably not perfect and will not suit everyone, but I am sure that it will find its buyer and gain its niche in the industry, and for some, it will become indispensable, as it has for me. You can see more examples of how this stabilizer is used on my channel in my previous videos from Japan. In this review, I tried to tell you more about the device, how and why it works, and what its features are. I hope the video will be useful to someone. Thank you for watching.